Hey guys, Mr. T here, still feeling a bit sick, but I just wanted to finish off this, the practice test, to help you out with the real thing coming up soon, on linear and exponential functions and their graphs. Hopefully, doing this you can see that it shouldn't take you long to do these questions. You just have to know what you're doing, and the whole point of that is that you are asked to do all of that stuff in the timeline. If you actually done the timeline, you remember what you did there, then you should have the hang of it and know what to do. So, starting off here, I've already used some of my time just talking. Question 1. The blank tables below show examples of variables x and y. So a bit of creativity here. A linear relationship, the only property there is that the variables increase by a constant amount each time. So I'll go 1, 2, 0, 1, 2, 3, 4, going up by 1 each time. And y can go up by a constant each time, so let's make it go up by 2 each time. 2, 4, 6, 8. It's my brother's cat. A nonlinear relationship, on the other hand, they don't go up by a constant amount. One of them could. X could still go up by a constant amount, but the other one would go randomly. So anything like this would be fine. Basically just being asked to making them up. It's a nonlinear relationship. Now, using the question 2, using the table of values below, explain why x and y are linearly related. X increases by how many? 1 constantly. And y decreases by 3 constantly. So it's an inverse linear relationship. The only thing that matters with a linear relationship is that the variables are changing by a constant amount each time. It can be decreasing or increasing, it doesn't matter, as long as both are changing by a constant amount each time. Extend the table of values up to x is equal to 8, so doing that up here, 5, 6, 7, 8. So it's decreasing by 3 each time, so going to there it's going to be 0. Next one is going to be -3, -6, -9. So that question is done up there. What will the value of y be when x is equal to 6? We can see that, it's on the table. X equals 6. Y is equal to -3. What will the value of x be when y is equal to 18? I'm just going to let that cat out. Put him in. Value of x be when y is equal to 18. So, it's another tricky one here. I'm trying to make it different to the textbook questions. Y is equal to 18 is not on here, but it would be back here if it was. Now, it's been going down by 3 each time, so it's gone up by 3 in the opposite direction. And for every 3 down, it's gone x plus 1. So if it's gone up by 1, going in the forward direction, it should go back by 1 to be -1 in the reverse direction. So when y is equal to 18, x would be -1. Alright, so that's that first 2 questions done. Question 3, Kanye the DJ. I'm obsessed with Kanye West. Not really, I just think he's funny and a bit ridiculous. Charges a booking fee of $90, then charges $50 for every hour thereafter. What's the independent variable? In this situation, why is it considered the independent variable? So, I'm going to think about this. It's not an experiment that we're doing, so it's a bit harder to think of what the independent variable is. You're not changing anything on purpose. So you have to think of it a different way. You have to think of the variable that's changing because of another one. The one that's changing because of another one would be the dependent, and so the remaining one would be the independent. So, independent variable would be the time in hours, because the independent time in hours, because the cost changes depending on the time take it. So because the cost is the dependent variable, it depends on the this variable that we're talking about, the time must be the independent variable. Alright, so it's almost a process of elimination there. Next, what is the dependent variable? We already established that there, so this should be easy marks. Dependent variable is the cost because the cost changes as a result of the time in hours changing. So because of the independent variable changing, the dependent variable also changes. The cost increases as the time in hours increases. And that's why it's dependent variable. So based on the information provided, will the two variables be linearly related? Explain why they would be linearly related. They would be linearly related. Time in hours would increase by a constant, see, an hour each time. Also, cost increases by the constant. It was $50 of $50 each time. So because they're both increasing by a constant amount, that would be linearly related. Construct a table of values for the above two variables up to 4 hours of work. So time in hours will be the X variable, cost in dollars will be the Y. 4 hours, so 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So at 0 hours, he charges a booking fee of $90. Increases by $50 each time. So 90 plus 50 is going to be 140. That plus 50 is 190. That plus 50 is 240. That plus 50 is 290. Table values done. Draw the graph of cost against time on the grid below. Use the proper label and scale. So the independent variable we said was time. So time in hours. You need the units there. The dependent variable is cost in dollars. So now you need to decide on a scale that will fit. We only need to fit 4 hours along the bottom, so that'll be easy. It can be 4 each. 2, 3, 4 right at the end. Now, you need to work out what scale will fit on the left side. If we count the boxes, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15. We've only got 15 boxes to play with. If you double that, that's 30. If you times that by 10, that'll be 300. If we could get 300 onto this scale, if we made it go up by 20 at a time. So 20, 40, 60, 80, 100, 120, 140, 60, 180, 200, 220, 240, 260, 280, 300 up to there, and that's going to fit everything we need. Change to blue. When time is 0, the cost is going to be 90. When time is 1, cost is going to be 140. When time is 2, it's going to be 190, so between 200 and 180. Time is 3, 240. Time is 4, 290. So, as before, I don't have a ruler for this iPad, so I'm just going to draw as straight a line as I can, and hopefully you can deal with that. There you go. You'd use a ruler in the test, okay? That's cost against time. Done. Next page. Question 4. Kanye West is a rap god and enjoys going on lavish spending sprees in his own store. On one of these outings, the amount of cash in his wallet was recorded. The results are shown in the graph below. So as you can see, as time goes on, the amount of money in the wallet decreases. Be careful. The scale is times by 1,000, so you need to keep that in mind. You can't just count squares. You need to keep that in mind when you're working out the gradient. Based on the graph, how much cash can Kanye's wallet hold, assuming it was completely filled at the beginning? Well, the Y-int is at 150, therefore wallet can hold, then reading off the scale, it's going to be 150 times by 1,000, $150,000. Find the gradient and Y-intercept of the line. So this is where you need to be careful when dealing with the gradient, because the scale is a bit more complicated than normal. Y2 take Y1 over X2 take X1. First step you're going to need to do here is decide on a second point. We have one exact point here. We know what the X value is and the Y value is of that point. You need to find another point on this line where it crosses grid lines very accurately. So if I look down, it looks like here is the best grid point. We'll call that point 2, this one point 1, and now we can find the gradient. Keep flipping it to the wrong layout. Alright, so the y coordinate of the second point is going to be 40, so it's going up by 10 each time, 40, 50, it's going to be 60. It's going to be at 60,000. 60,000. Take the y coordinate of the first point, which is 150,000, divided by the x coordinate of that second point, which is 70, down there, and the x coordinate of the first point is going to be 0. So up here, 60,000 take 150,000 is negative 90,000, divided by 70 take 0 is 70, and that comes to a little bit of a decimal point answer, negative 1285.71 to 2 decimal points. That's the gradient. And the y-intercept, easy to read, y-int is going to be 150,000, which we established before. So the equation, cost in dollars, is going to be the gradient, negative 1285.71 times by t, plus the y-intercept 150,000. Why is that? Because lines in slope-intercept form, or gradient-intercept form, are y is equal to mx, which is m is the gradient, plus c, which is the y-intercept. There's our equation. Interpret the meaning of the gradient in terms of the amount of cash used and the number of minutes passed. You got a couple of options here, but the easiest one, because you've already worked out the gradient and the y-intercept, is just to use this gradient, because it's telling you how much it changes per minute, per time. So it's saying that, therefore, $1,285.71 in cash is used by Kanye every minute that passes. So he's burning a bit of cash there. Use the equation connecting C and T to determine the amount of cash left in the wallet after 90 minutes. So we've got our formula, but we're interested in what happens at 90 minutes. Negative 1285.71 times by 90 plus 150,000, sorry. That comes to negative 115,713.90, approximately plus 150,000 because I rounded that to 2 decimal points. So that comes to $34286.10 to 2 decimal points. Therefore, he has $34,286.10 left in wallet after 90 minutes. So that's question 4 done. Use the equation connecting C and T to find how long it will take for the wallet to be completely empty. So using that formula again, but we know that we're interested in an empty wallet, which is going to be 0. The same gradients, 150,000. The opposite to adding 150,000 is taking 150,000. So take 150,000 from both sides. You'll end up with negative 150,000 on the left side and negative 1285.71 T on this side. The opposite of timesing something by negative 1285.71 is dividing by negative 1285.71. So T is going to be negative 150,000 if we divide both sides by that. Negative 1285.71. Time is going to be, get a calculator, and T is going to be approximately 116.67 to 2 decimal points. Therefore, it'll take him 116.67 minutes to empty the wallet. That's pretty quick. Using the grid below, so question 5, using the grid below, graph both of the following linear equations using the same scale. So this time, the first line is in general form, 5x plus 2y is equal to 10. Y int is when x is equal to 0, so we substitute x being 0 into that. 5 times 0 is 0, so all you're going to be left with is 2y is equal to 10. Opposite of timesing something by 2 is dividing by 2, so 10 divided by 2 is going to be 5. X-intercept is when y is equal to 0, so this time we know that y is going to be 0. 5x, 2 times by 0 is going to be 0 is equal to 10. The opposite of timesing something by 5 is dividing by 5. 10 divided by 5 is going to be 2. So we know that line. Let's go over to this one. Gradient is y step over x step. We know the gradient is negative 2, so negative 2 as a fraction is negative 2 over 1. So we know therefore 1 step across, 2 steps down for this gradient. Y int is just given, it's positive 2. So we have enough information to draw the lines here. Sorry about the sniffling, I'm just feeling a bit dodgy. Cartesian plane drawn on here. I'm not going to draw the units on, it takes too much time. So actually I'm gonna do this line in blue and this line in black. So the black line first, y-intercept of 2, and for every 1 step across it goes 2 steps down. So 1 step across, 2 steps down, 2 steps down, 1 step across, 2, 1 step. Alright, so we have enough information to draw this first, the black line, the one in slope intercept or gradient intercept form. Not the best drawing here because I have no ruler. You would draw that with a ruler in the test. Y is equal to negative 2x plus 2. Label the line. Now I'm going to draw the other line. It has a y-intercept of 5. 1, 2, 3, 4, 5. It has an x-intercept of 2 there. So, not going to be the best line again, but you can deal with that. closer and closer there. So that line is 5x plus 2y equals 10. Label it correctly. Next, using the graphing function of your graphics calculator, answer the questions below regarding functions of the form y is equal to a times bx. So, these are the only functions we deal with in this course, and we've spoken about in class and with some of your questions on the timeline how changing a and b changes the shape of the graph. The first thing you should have learned is that a is the y-intercept. So for the function y is equal to 2 times by 0.5 to the power of x, what is the y-intercept? Y-intercept is just going to be 2. Alright? For the function y is equal to 2 times by 0.5 to the power of x, does the graph curve up to the right or up to the left? So I've suggested in this question you can use your graphics calculator to help you out, but it's just asking what happens with a graph, so you don't need to draw anything. You can just use it to help you. So I'm going to, because I can't show the graphics calculator on the iPad Pro, I'm just going to sort of give you an idea of what they look like. So this function here, 2 times by 0.5x, when I draw that on the graphics calculator in the y equals option, it sort of looks like this a little bit. It's not going to be exact, but it'll be pretty close. That one, y is equal to 2 times by 0.5 to the power of x. So that's sort of what it looks like. So what does it curve to? It goes up to the left is my answer to that question, because it's going up on the left side. C. Describe what happens to the steepness of the curve if the function is changed to y is equal to 2 times by 0.1x. So if you graph that in your graphics calculator on the y equals function, you'll notice that it does still have the same y-intercept of 2, but it's closer to the y-axis, so it looks more like that. So it's gone up and down a lot quicker than the other one, so you could describe that as being steeper. The curve gets steeper with that function there. So when you've changed b from 0.5 to a smaller number, 0.1, it gets steeper. For the function 2 times by 2 to the power of x, does the graph curve up to the right or up to the left? So when you draw this graph, it still crosses at the y-intercept of 2, but this time it looks sort of like this instead. So it's the other side. So this time it curves up to the right because it's going along there and then up to the right. Describe what happens to the steepness of the curve if the function is changed to y is equal to 2 times by 3 to the power of x. Well, if you draw that, I'm not going to draw it exactly, but you'll see a curve that's closer to the y-axis this time. Still curving up to the right, but it's closer to the y-axis. So the curve gets steeper again because it goes closer to vertical a bit quicker. So what you'll notice there, hopefully, is going to be summed up in this statement below. Using your findings above, fill in the blanks for the statement below regarding functions of the form y is equal to a times by bx. So these are the functions we've only looked at. So for functions of the form y is equal to a times by b to the power of x, a is we established that from part A is the y-intercept. If b is between 0 and 1, then the graph curves. Well, the only examples that we did between 0 and 1 were here and here. And what do we notice? They curved up to the left. Up to the left. If b is greater than 1, then the graph curves. Well, we noticed that when we graphed that, then we graphed that, they curved up to the right. And what else did we notice? As b gets closer to 0, so as b got closer to 0, it started off at 0.5, and we got closer to 0 down to 0.1, the curve got steeper, which is that blue line there. So as it gets closer to 0, it becomes steeper, and as b gets larger than 1, what do we notice when we graphed this one? This curve here, the line got steeper, so as it gets larger than 1, the curve also gets steeper. So hopefully that sums that up. You're not going to get the exact question in the final actual test, but you can have something where that particular question will help you out a lot. So that is 6 done. Last question here, so it's solving an equation in a practical context. Unlike most artists, the popularity of Kanye West music decreases over time. Hence, the value V dollars of a signed Kanye West album Y years after the purchase given by the equation 2000 times by 0.75 to the power of Y. What was the original value of the signed album? Well, you could use maths if you weren't sure, because the original value is going to be when it's been 0 years. So to the power of 0, anything to the power of 0 is 1. 2000 times by 1, it's going to be $2,000. Therefore, original value of $2,000. By what percentage is the value of the album decreasing each year? So hopefully doing your exercise, you would have noticed that change it to a lightsaber. You've noticed that in the practical applications of the exponential equation usage, that this b in this form, because you might remember that exponential functions that we've been looking at have this form. So this 0.75 is b. You'll notice that that is actually a percentage of the original thing. So this situation is actually this original number changing by a certain percentage every year. And this number b corresponds to what percentage is left of the original value each year, because it's less than 1. This is a fraction, 0.75, so 75%. So what that's saying is every year value is 0.75, therefore 75% of what it was previously. So if it's being 75% of what it was before every single time, it's decreasing, therefore decreasing by 25% every year. Because if you have 75% of something, it's been reduced by 25%. So answer to that, find the value of the signed album after 6 years. So you can use the formula. V dollars is going to be 2,000 times by 0.75 to the power of 6. If you chuck that in your calculator, you will get approximately $355.96 to 2 decimal points. So after 6 years, valued at $355.96. How long would it take for the value of your album to be half of its original value? So, unfortunately I can't show you what I'm doing on the calculator. I'm just going to write what I've done. So first step is to work out what value you're interested in. You're solving an exponential equation, and you need to do the extra thinking because you are trying to work out where the graph intersects when it's half of the original value. Half value is at $1,000 because the original value was 2,000. So that's half. So on graphics calculator, on GCalc, press Y equals, clear everything if it's got stuff in there, and graph Y1 as your function, 2000 times by 0.75 to the power of x. In the Y2 line, you graph the straight line that you're interested in, the level that you're interested in, 1000. Hopefully you've cleared everything else. Now you press graph, and what you'll probably see is nothing. Unless you're really lucky. Why? It's because the graphics calculator zooms to a window of like -10 to +10 in the X and -10 to +10 in the Y direction. Your graph is going to start at 2000 and work its way down, so you're not going to be able to see anything. So what I've taught you is to try to get the calculator to zoom for you. So press zoom, select zoom fit, and then it will try to work out what the most interesting parts of your graphs are and get that onto the screen. And so when I've done that on the calculator just now, it actually finds it very well. So now press second and trace, then select intersect or intersection, whatever it comes up as. Then the graphics calculator asks you first curve. Check that it is actually check. It says the first curve that you put in, which was y1 is equal to 2000 times by 0.75 to the power of x. Press enter. When it does that, so I'm doing this at the same time, trying to keep up. Second curve. It asks again once you press enter. Check that the second thing that it's selecting says the second line that you put in, which was y2 is equal to 1000. If it is, then press enter. It says guess after that, and you don't need to check anything, just press enter. You're just asking the calculator to find where the intersection is. Then it should come up with the result of intersection. X is equal to 2.41 to 2 decimal points. It's got a whole long number there, but just round it to 2. And Y is equal to 1000. This is the one that you're checking that is correct. It's telling you it intersects at 2.41 and 1000. And the Y should be this one here, because you want it to be lining up with the line at Y is equal to 1000. So that should be correct. So what that's saying is the point of intersection is at intersection at 2.41 and 1000. Therefore, it takes 2.41 years for the value of the album to halve, which is $1,000. Alright, so that is that. That's the last question of that practice test. The real test is about the same length. Make sure you do this as preparation, and see you on the next video.